issues regarding the last shade exercises?
Nah.
No, sir, I don't think so. Very easy topics, anyways.
Very good. Okay, we did till triangles. Did I share this one as well?
Uh, this one no, yeah, so you did. I think
Yeah,
so.
we did.
Yeah,
Okay.
you did.
Okay. There are two basic triangles. You would remember this. Like if we have a square sided one each, and now I'm extracting one triangle. So when I have this triangle, this is 90 degrees. That was one. This diagonal making it 45 degrees. And this side as square root 2. Before I continue, just try one question. If I tell you that this is a square and another square inside this one, this is diagonal of 24 square root 2 and the width of all sides is 3, and we have this shaded region. Question is find the area of shaded region. This question used to be in the non-calculator section, but now we have calculator in both the sections.
So can you show the question?
I'm sharing screen.
Oh no, oh, this is just a normal concept. I thought you were explaining a question.
Yeah, this is the question. You have to find the area of this shaded part, the
Okay.
red section. Dimensions are diagonal of inner square is given and the thickness of the shaded part is given.
So it's a square, right? Sir?
Can you please make it a little louder? I can't hear you.
I asked if it's a square.
Yeah, both are squares. I'll try to make more clear. Diagonal is 24 square root 2 and this thickness is 3 on all sides.
No, I got an answer.
Yeah, sure.
324 units squared.
Very good. Would you care to share how you did that?
All right. Should I wait for Mahat to finish first, or?
No, no, you share it.
Okay, sir. So, since it's a square, both sides of the right angle triangle inside the square will be equal to each other. So I wrote 2a squared equals brackets 24
Very,
root 2 squared.
very good.
I
So,
expanded that. Yeah.
I'm just writing it what you're saying. So basically, you used Pythagoras theorem,
Yeah. So I got 2x squared equals 1152. And if you simplify that, a is equal to 24.
and you solved this for 24.
Yeah.
And then yes, so this is 3. Now this is 24, and this is 3 again.
So the length of each of the sides of the bigger square is 30 and the smaller is 24. So I just did 30 squared minus 24 squared, which is the area of both squares subtracted from each other.
Now what I'm trying to do here is, Mad, are you listening to us?
Yes, sir.
Okay. Now what I'm trying to do is that make you understand that you can always skip this part. Whatever you said is 100% correct, and you actually took the time which was very well. That was not late. I think you have a strong grip on this. So coming back to this, we know this is 1 and square root 2. So if anywhere you see a triangle, which you definitely know is an isosceles triangle with 90 degrees right angled isosceles triangle, you would know these are 45, 45, 90, and like in this case in the question. So if someone has written 7 over here, you would automatically know that this is 7 and this is going to be 7 square root 2. Reason being similar triangles. Getting the point? If I draw that again and I just write that this side is 13, can you tell me what is x and y? X is equals to
Are you asking me or Mahat, sir?
anyone, just class discussion, both of you.
So the angle at the bottom right is 45 degrees, right?
Yeah,
And the top one is okay, good. I read the top one as 13, which is why I was
that was
confused.
that was my mistake.
So
So
we could
x
just use
is
SOHCAHTOA, couldn't we?
So tan inverse.
no. Just observe. If this is 1, this is 1 because that is isosceles.
Oh, so it's also going to be
If
13.
this is 7, this is 7.
It'll be 13 as well.
That will be 13 as well. So if this is 13, this is going to be 13 because it is isosceles. So when it is isosceles with 45 angles, 1, what is that? Square root 2. This is 7, 7. What is that? 7 square root 2 because I've enlarged the triangle 7 times. Now what's happening? 13, 13. So why would be 13 square root 2? Another try. If this is, whenever I want my diagram to be perfect, that is the time it slides away. If I say that this is 4, 4, what would be y?
It would be,
Don't use Pythagoras theorem, just compare.
yeah,
Is this triangle 4 times larger?
it is, yeah.
So every side would be 4 times larger. If I make another triangle and I tell you that this is 40 and the angles are 45, 45, 90. So what is this x equal to?
So it'd be
Would it also be
40
40?
root, it'd be 40,
40. And what is this y equal to?
40 root 2.
40 root 2. So basically, we are going to memorize this. You have to break two things. One is you would have always heard that O levels, A level, Edexcel is concepts, no learning. In SAT, we are going to learn few things which you luckily already know. Secondly, you have to make your mind that working is not important. The path is, and the correct answer is, because even if your answer is 99.9% correct, but you choose a different option, examiner is going to get only the bubble sheet, no working, nothing. If this was a question in your structured questions, out of 4, even if you make one mistake, you'll still get 3. But in SAT, it is either 1 by 1 or it is 0 by 1. Getting it? So we're just going to save our time. And this is one of the triangle which we have to memorize. And the other one is, this is 1, 1, square root 2, 45, 45. And the other one is, if you consider an equilateral triangle of side 2 each, I'm going to split this into half and bring down my desired triangle. Now this is 90, that was 2, this is 1, this was 60 because it was equilateral. The top one makes it 30, and when we use Pythagoras theorem, I get it square root 3. And in the same manner, if I just draw another triangle and I tell you that this is 14, what would x be?
Hmm.
Just compare these two. What would x be?
7.
7, right? And what would y be?
Root 21.
That is 7 root 3. See, this
It's still
side
root
is
21, right?
7 times larger. No, no, not root 21. When 7 actually goes inside, it becomes 49.
Ah, I thought because if you look at the triangle on the left, I thought
Yeah. So that
it was an
luckily proves my point that you have to memorize few things. Don't go into logic of everything. So that's actually root 147 equals to 7 root 3. Like 49 into 3. 7 square into 3 or 7 root 3. You were actually, I think, trying this thing. So 2, 7 times. Every side increased 7 times. So whenever I will see this triangle, I will not go into Pythagoras theorem. If I see that this is 60, 30, and 90 degrees, and someone has written 13 over here, I would know that this is double and this is 13 square root 3. Okay, without thinking, you would have seen this a lot. If I just write 3 here and 4 here, you would automatically know y is value of y. Are you using Pythagoras theorem? Can you hear me?
Yes, we can hear
yes.
you.
So basically, 3, 4, we know this is 5. So if I just write 6 and 8, then z would be equal to
10.
10. So there are a few things we just have to break this norm that we have to write every step. By not writing every step, we are saving our time. And few things are like, you call it educative guess, because there are options as well and you will straight away get to it. Let's try a few questions. This topic uses Pythagoras theorem and there will be touch of the topics we've already done. So question number 1 is ratio and Pythagoras theorem. The length and width of the rectangle are in ratio 5:12. Never confuse ratio with the actual length. This may be 500 and 1200. So it is 512, but what are the actual lengths? I don't know. So I can write 5x and 12x for original length. If the rectangle has an area of 240, now that's ratio and original area is given. What is the length in centimeters? So length into breadth, 12x into 5x is equals to 240. 12 into 5 is 60. X square equals 240. X square is equals to 4. X is equals to 2. So I now know that this is 10 and this is 24, the actual length. So length of diagonal is 10 square plus 24 square whole square root. And I'm getting 26. And this brings me down to 13, 12, and 5. Try question 2.
Is the answer 10?
Yes.
Yes, I'm also getting 10.
Very good. Now try question number 4. Let me zoom out. Question 4.
6 through 3 pi?
Is it B part?
Yes, question number 4 is B. So the question said 36 equilateral divided by 3. This is 12, 12, 12. When you just split it, you know this is 60, 90, 30. So when I actually see that this is 12, 6, and 60, 30, 90, I already knew because I've learned it that this was 1, 2, and square root 3, double and square root 3. So this is 6, 12, and 6 square root 3. So I'm just looking at everything being multiplied with 6. So I know the height and I know the base, and I can find the perimeter, radius, area, or anything, whatever is required. So if this is 6 square root 3, although you've already done it in a very good time, I'm still imposing that. Okay,
Let's go.
let's try circles. I'm leaving few questions for practice, and the next topic is circles. A very quick recap of formulas. Okay. Okay, yes, we did the triangle 30, 60, 90. Fine. Just had to make sure. So any problem out of this?
No, sir, I don't think so. I
Did you
did
get
all the. No, I didn't. I think most of them. इसलिए वो कल मुझे कहीं जाना पड़ा था लेकिन I can definitely finish all the circles in this today.
कोई बात नहीं, कोई बात नहीं. एक थोड़ा सा स्किम स्कैन कर लेते हैं quickly.
ठीक.
Did you try this one? Question 2.
Question 2. हाँ जी मुझे लगता है. मैं फिर से ट्राई करता हूँ, एक मिनट। With an altitude 6,
Yes.
अगर 6 है तो मतलब
So basically, we have this. If I draw that split,
also, is it B?
that's correct.
Okay. So how are you gonna explain it?
Using similar triangles, 1, 2, square root 3, 60, 90, and 30. And I was going to use this to find this radius. That square root 3 over 6 is equals to 1 over radius. And then cross multiply. So radius is 6 by square root 3. Sorry, I'm calling that radius. Let's say that's x. And then the twice is full breadth, full base. So 1 by 2 into full base is 12 by square root 3 into height is 6. 1 times 2 times, that is 36 by square root 3 into square root 3 by square root 3. So we get 36 square root 3 over 3, ultimately resulting as 12 square root 3, option B. Some students prefer to use sine cos tan,
Yes, so that's
which is
we did use sine cos.
okay. Question 4, we are going to find PS. Before that, I'm looking at PQ. This is 16. This is 20. Using Pythagoras theorem, I'm getting 16. But why I'm getting 16? Just by reading it, how I'm getting that?
20 squared minus 5 squared.
Yes, minus 6. That is
60, sorry, 60.
and 5, 16. So this is 12. This is 12. I wrote 16. See, do you remember that using 4, 3, we directly write 5? But somehow we used it so much that we remember.
Yes, sir. Like, no, what do you mean?
Like if we have two sides, 4 and 3, the third one is always 5.
Yes.
And if we have 6, 8, somehow we know that this is 10. Actually, that's twice of that. So which brings me to this, that if I look closely, all these sides are 4 times. So
Yeah.
3, 4 times is 12. Now we have 12 and 5, and there are two reasons, like solving them again and again and teaching this to different classes. It's just like stuck in my mind that whenever I use 12 and 5, I get 13. Like 24, 25, and 7 as well.
So it's like a shortcut.
Yeah, because somehow you know back in back of your hand that you just have to fill the bubble sheet correctly. Examiner is not interested in the working. When we are doing structured questions, our approach is different. We do not miss any step. So just increase number of questions. So at least we get that hint that this could not be the answer when we are solving. Okay. So these are simple, but please don't miss any. In your free time, do go through them. Okay. Number 14. Same question. Did I
He said he was taking a shower.
Okay.
Time for another. So what? Question 14. Or
Yep.
should we wait for a Should I try it or should we wait for a Basi?
Yeah, go on, try it.
Okay.
We'll join in a while. Assalamu alaikum.
Like,
Mohammed, quickly try this 14th question.
14.
Yep.
So is it 2 square root 2 plus 2 square root 3?
That's correct. So if you remember this triangle 30, 60, 90, and the other one 1, 1 square root 2 with 45 degrees. ADE, this first section, is 30, 60, 90. And luckily, this is 1. If this would have been like 7, this would have been 14. And we'll be writing, sorry, this was 2 and this is square root 2
I
and
got for the A.
yeah, that's correct. So I'm just using similar triangles. Luckily, that's exactly same, so that would be congruent. 2 and square root 3, and then I'm looking at this triangle 2, 2, 2 square root 2 without working, just using similar triangles. And this last one again makes it 1 and square root 3. Mohammed, are you also getting the same answer?
Yeah, sir.
Try this 20th one, then we move on.
Sir, is it A?
That's correct.
Is it A? Oh, it's above.
Yes, that's correct. Okay. Question number 5. Is it readable?
Yes, sir. Sir, is it C?
That is correct. C.
Yes, sir, I did see.
Okay, then we did